Welcome to section 1.1 on limits. First of all, we start out with the definition of a limit. Assume that a function f of x is defined for all x near c in some open interval containing c, but not necessarily at c. We say that the limit of f of x as x approaches c is equal to L. That is how we read this statement. It's important to note that C and L are constants. Sometimes they are finite, sometimes they are infinite, but it's important to know that L, in order to exist, must be a finite value. So what exactly does this mean? Well, let's take a graph here. Let's say we have an x value of C and a y value of L. We have a graph, let's say, that looks like this. So as we are moving along the curve here, we are approaching a y value of L as we come from both sides here. It is also important to note that let's say we have a point here at Cm. So f of C is equal to m. If that is true, that doesn't change the fact that the limit as x approaches C of f of x is equal to L. So let's look at a few examples here, okay? The existence of a limit. The function's value must approach the same value from both sides of C in order to exist. So, for instance, we would say that the limit as x approaches C from the left of f of x, okay, so we need to understand that notation. When we have a superscript of a negative sign, that means from the left. That value must equal the limit as x approaches C from the right of f of x. So if those two values are both L, then we can say that the limit as x approaches C of f of x is equal to L. If those two things are not equal, then of course we would say that the limit does not exist. Now, also, if a function is not defined on one side of C, then we would also say that the limit does not exist. And many times we would just write DNE. That is a generally accepted way to make that statement. So, for instance, let's say that we have a graph here. Here's L, here's M, and here's C. And let's say that the graph comes from the left towards a value of M and from the right towards a value of L. We would say that this limit does not exist because L is not equal to M. Or in other words, the limit as x approaches C from the left of f of x does not equal the limit as x approaches C from the right of f of x. Most of the time, we are going to have a situation like this where the graph comes in from the left approaching L and from the right approaching L, and therefore then your overall limit will exist and be equal to L. So let's take a look at some of these examples. First of all, we are going to find f of negative 2, then the limit as x approaches negative 2 from the left of f of x, the limit as x approaches negative 2 from the right of f of x, and the limit as x approaches negative 2 of f of x overall. All right, so first of all, f of negative 2. All right, so just a reminder, this has nothing to do with the limit question. So f of negative 2 means what is the y value on the graph of f when x is negative 2. So if we look, that is the y value right there. So that is negative 1. F of negative 2 is negative 1. Now we can move on to the limit question. The limit as x approaches -2 from the left of f of x. So we are moving along the curve from the left, and we are approaching a y value of 3. The limit as x approaches -2 from the right of f of x. Once again, we are moving along the curve from the right, and we are approaching a y value of 3. Therefore, the limit as x approaches -2 of f of x, well, we have to look at the limit from the left and the limit from the right. Those are both 3, and therefore the overall limit as x approaches -2 of f of x is equal to 3. On to the example on the right, f of -2. First of all, f of -2. What is the y value on the graph of f when x is -2? So we see that there is an open circle here. There is an open circle here. There is no closed circle when x is -2. Therefore, the function is undefined. Now, if one of those was a closed circle, then the y value of that closed circle would then be the value of the function. However, what if both of the circles were closed? Well, that's kind of a trick question, because then this thing would not be a function because it would fail the vertical line test. All right, what about the limit as x approaches -2 from the left of f of x? All right, so we are moving towards -2 from the left. We can see we are approaching a y value of -2. What about the limit as x approaches -2 from the right of f of x? If we are moving from the right, we can see we are approaching a y value of 1. Those two numbers are not equal. Therefore, the limit as x approaches -2 of f of x does not exist, or we would write DNE. All right, a couple more examples. All right, f of -2. So first of all, f of -2, we look here, there is a dotted line. Okay, that is a way that we indicate the existence of a vertical asymptote. There is no closed circle, and so we would say that the function is undefined at x equals -2. The limit as x approaches -2 from the left of f of x. So now remember, we are moving towards -2 from the left. We know how a vertical asymptote works. This graph would continue to go down forever and never actually reach -2. So we say that we are approaching a value of -infinity, which isn't actually a value, okay? But it's an idea that helps us understand the nature of the graph. All right, now the limit as x approaches -2 from the right. In the same way, we are going up towards positive infinity, so we would just write infinity. Now, one of these is a negative number, one of these is a positive number, so clearly they are not equal. So we can say that the limit as x approaches -2 of f of x does not exist. Now, just to have the discussion, what if both of these were going up on either side of the vertical asymptote? They would both be positive infinity. However, infinity is not a number, it's a concept, and therefore we would have to say that the overall limit does not exist as well. So in order for a limit to exist, this must actually be a number, and infinity is not a number. All right, let's look at this example on the right. F of -2. All right, we are looking for the y value when x is -2, which is 1. Let's go to the limit as x approaches -2 from the left of f of x. So as we move along the curve from the left, we are approaching a y value of 1. The limit as x approaches -2 from the right of f of x, we are also approaching a y value of 1. These two are the same, and so the limit as x approaches -2 of f of x is equal to 1. All right, so now one more picture here. Let's take a look at all of these questions on the right. First of all, the limit as x approaches -4 of f of x. Be careful here. -4 is right here. The curve goes through that spot, and so there is a point there. So that means from the left and from the right, we are approaching that same y value of +3. So it's important when we ask this question, we need to consider both from the left and from the right in order to answer that question. All right, but now the next one, the limit as x approaches -3 from the left. So if I am moving along this horizontal line from the left, I am approaching that open circle of 3, but that is the y value that I am approaching. All right, what about the limit as x approaches -3 from the right? Now I'm moving along this curve from the right of -3, and I can see I'm approaching a y value of -1. Now, once again, it's important to note it does not matter which one of those circles is filled in, or if either of those circles are filled in for the limit as x approaches -3 from the left or from the right. All right, what about the limit as x approaches -1? Notice there's no superscript there, but we do need to consider both of those. So limit as x approaches -1. So from the left is 2, from the right is 1. Therefore, that limit does not exist because the limit from the left and the limit from the right are not equal. All right, what about the limit as x approaches 1? The limit as x approaches 1 here is 1. We are going down towards -infinity and down towards -infinity. Yes, those are the same, so oftentimes people want to write -infinity here, which is fine, but we also want to say does not exist because -infinity is not a number. What about the limit as x approaches 3? So here is 3. From the left, we are approaching +infinity. From the right, we are approaching -infinity. So the only thing that we could write is does not exist. All right, limit as x approaches 5 from the left. All right, here is 5. So from the left, we are approaching a y value of 1. And from the right, we are approaching a y value of -3. And had we asked the limit as x approaches 5 just overall, we would have to say that it does not exist.